If 1 plus I by 1 minus I to the power m equals to 1, then find the least positive integral value of m. Pause the video, give this a try. Alright, let's do this together. We have this expression to the power m that's equal to 1. Now, if m is 0, this expression raised to the power 0 that's equal to 1. But we're asked least positive integral value. So we need to try values like 1, 2, 3 and 4. That's one approach. But the other approach is to simplify this expression 1 plus I by 1 minus I. Let's see what we have here. Let's rationalize 1 plus I by 1 minus I first. This means we'll have to get rid of this I in the denominator. We'll have to make this denominator real. So how do we do this? We multiply the numerator and denominator by the conjugate of the denominator. So if this is 1 minus I, we'll multiply and divide by 1 plus I. So this expression becomes 1 plus I by 1 minus I times 1 plus I by 1 plus I. Now let's multiply these two in the denominator and these two in the numerator. We have 1 plus I squared in the numerator. That's 1 plus I squared plus 2, 1I, that's 2I. And in the denominator, we have a plus b times a minus b. So that's a square minus b square. That's 1 minus I square. Now I square is minus 1. So let's replace it. This is what we have. 1 minus 1 plus 2i divided by 1 minus minus 1. So this becomes 1 plus 1. So in the numerator, we have 0 plus 2i, which means 2i. And in the denominator, we have 1 plus 1, that's 2. 2 cancels out. This becomes I. So this expression is actually I, which means we can rewrite the question. We're asked if I to the power m is equal to 1, then find the least positive integral value of m. Now we can raise I to all integral values and check where we get 1 first. That's probably 4, but let's still check. I to the power 1 is I square is minus 1, I times I is minus 1. I cube is minus 1 times I, that's minus I. And I to the power 4, that's equal to 1. This is the first time we get the value 1. So this means the least positive integral value of m, that's equal to 4. Let's try another one. Find the number of non-integral solutions of the equation mod of 1 minus I to the power x equals to 2 to the power x. Pause the video, give this a try. Alright, so the question says non-zero integral solutions. We don't want 0. We want only non-zero solutions, because what's happening at 0 is both the sides are raised to the power 0. So both sides are equal to 1, which means it's a trivial solution. So we need some non-zero integral solution here. Let's see what we have. On the left hand side, we have a mod of 1 minus I, mod of a complex number. That's square root of real part square plus imaginary part square. So that's square root of 1 square plus 1 square. That raised to the power x, that's equal to 2. So this becomes 2, which means we have root 2 to the power x, that's equal to 2 to the power x. This is 2 to the power half to the power x, which means we have 2 to the power x by 2 equals to 2 to the power x. So we can compare the powers. X by 2 equals to x, which means x minus half is equal to 0. Be careful, you can't just cancel x here. It's better to put everything on one side and then equate that to 0. So x minus x by 2 is 0, which means x by 2 is 0, which means x is 0. So the only solution that we're getting is x equal to 0. And that's not something that the question asks for, which means there are no other solutions. There is no other value of x that satisfies this equation.